today when we are doing lesson 1.5, tell me then how many vocabulary words were there in lesson 1.5? Jared? Just one. What was it? Identity. And we're going to get to that in a little bit, but how many of you already have that vocabulary word defined in your notes? And something that makes sense to you. Okay? Good. Well, what's the first objective in this lesson? Courtney?
Solving equations with variables on both sides.
Solving equations with variables on both sides. Okay. So that means you got maybe x's on the left side of the equation and x's on the right side of the equation. What do we do when we've got variables on both sides? What did you learn about when you have variables on both sides while you were reading, taking your notes, practicing some problems? What did you learn? Jacob?
You have to be able to get it on one side.
Yeah, you gotta get it, those variables are on only one side or the other. So you're gonna have to do an inverse operation, right? That's going to remove them from one side or the other. Just like we do when we do constants. When we're trying to get rid of constants, we do the inverse operation. We can do the same thing with variable terms also. Okay, so what's the second objective in our lesson? Lesson 1.5. What was the second objective in this lesson? Jared?
Simplifying each side before solving equations.
Oh, simplifying each side before solving equations. Well, we already knew that. We just did that in lesson 1.4. Simplifying before solving, correct? We said simplifying is not the same as solving. What is simplifying? What is that? We don't need a technical term. Just tell me what simplifying is. If it's not doing the inverse operation and having to worry about keeping the equation balanced at that point, what are we actually doing when we're simplifying? Courtney?
Like breaking down.
Yeah, breaking it down. In other words, maybe making it more compact. Have you ever noticed that when you're simplifying, you usually make the equation more compact, maybe a little bit more user-friendly? Okay, so today I'm going to guess then that since we already know how to simplify an equation, we know that when you have like terms on one side or the other, you can combine them. We also know that if there's any multiplication over addition or subtraction to do, we do the distributive property. That's a simplifying step. Well, today I'm going to guess that what's going to happen then is, and this probably happened in your practice, is that when you're simplifying and you're done simplifying, you still have variables on both sides. Did that ever happen? You had to simplify. When you were done simplifying, you had variables on both sides. So then you had to go now to what you just did in the previous objective that says, now what do you do when you've got variables on both sides? Okay, are there any other objectives in this lesson? Were there any other objectives in this lesson? I think there was a really important one that might have been a bit confusing. I'm not sure if it was or not for you, but what was the third objective in this lesson, Braden?
Infinitely many solutions or no solutions.
Infinitely many solutions or no solutions. Now, so far when we've been solving these, we've gotten one solution for the variable, right? But they're telling us that sometimes the solution set might be an infinite number of solutions, or it might be no solution at all. So it sounds like we have another situation that can happen in our solving now also. Okay? Do you have any prior knowledge of that? Have you done that in the past? Have you ever solved equations when you found out that there were an infinite number of solutions? What does infinite mean? Never ending. Have you solved equations where there's a never-ending amount of solutions? You should have. How about have you ever solved equations when there's no solution? Prior knowledge, I'm not talking about what you're reading here. Did you have some prior knowledge of that? Good. Okay. So we'll be doing some of that. What else is there? Are there any other objectives in this lesson? Any application?
Yes.
Oh, yeah. Pretty much every lesson they end with an objective, making sure you understand how to now apply the other objectives to an application problem. Okay, so carrying on in your notes, you can start a new page or you can carry on in wherever you left off in your notebooks. We're going to put down that we're going to be working from page 43. That's where we're getting these problems from. It's page 43. And we're actually going to do, I think these come from the guided practice exercises, am I right? You want to turn to page 43 and tell me? Is number 8 from the guided practice? Yeah? Okay. Apparently I thought we should go right to a problem like that, and I should make sure that you understand how to do these. Okay? So I must have skipped over the first objective and went straight on to the second objective. So let's write down the equation that they give us in problem number 8. Okay, it's a pretty long equation. What would you suggest would be the first thing we would do to attack this lengthy thing? Jacob?
Distributive property.
Distributive property, some simplifying in other words, right? Okay, well, the first thing I'm going to do is I always like to change my addition to add the opposite, or my subtraction, I mean, to add the opposite. There's only one subtraction going on in there. And trust me, you'll be far more successful because, especially if this had been subtraction right here, that would have really complicated the matter, but the good news is this one's addition. Okay, so we're going to do distributive property, and we have distributive property to do on both sides. So let's do it all in one step here, huh? So the 5 just comes along, and we have 3q plus 3 times negative 4, negative 12, and the other side becomes 2q plus 2. Okay. Are we done simplifying? No. Which side can still be simplified some more? The left side can still be simplified. What can be put together on the left side? 5 and the negative 12. So what does that become?
Negative 7.
Negative 7. 5 plus negative 12 is negative 7. Okay. What do you think? Do you think we're done simplifying finally? Are we ready to start solving? And solving means you do the same thing on both sides of the equation. So what do you want to be your first move? Typically, you want to get rid of the variables first. You got variables on both sides. Let's deal with the fact that we got variables on both sides. And the other thing you want to do is you want to get rid of them on the side that when you take care of it on the other side, it's not going to create a negative for you. Why create negatives? You don't need them, right? So which side do you think we should get rid of the q's on?
2q.
The 2q. Let's get those out of here. So if we take the 2q away on that side, then we have to take the 2q away on this side. Now, if there aren't any q's to take away on the other side you know that you're doing something you don't need to do, really. So what's our equation read now?
Negative 7 plus q equals 2.
Negative 7 plus 1q or q. 1q is just q, correct? Equals 2. Okay, go ahead and finish solving that equation. Did you get 9? How do we feel about 9? Do we think it's a pretty good solution? Well, how would we know? We plug it in. We go all the way to the very beginning. We put it back in. We do the mental math. Let's just do mental math here. 9, it was take away 4. What's 9 take away 4? 5. What's 3 times 5? 15. What's 15 plus 5? 20. Okay, so the left side becomes 20. Keep that thought. Okay, right side. 9 plus 1? 10. 10 times 2? 20. What was in the other side? 20. 20 and 20. Are we good? Yeah. Okay. Any questions anywhere along the way that we, lost you? You want to go back and say, why did we do that there? Or can I change your mind, Mrs. LeBrand? Or no? Then would you write down problem number 9, the next one in the exercises? Number 9. And remember, we can, even though the book uses like variables we might not like, we can change them if you want. So if you wanted to change t's to x's, feel free, it's okay. The better thing to do if you're not going to change them though is to write them as a cursive t rather than a printed t, because the printed t looks far more like the addition sign, right? Okay, this is a tricky one. Anybody have any suggestions for us to get us started? Because if I just let you loose on this all by yourself, I can almost be guaranteed that we get about 4 or 5 different answers in here. So let's try to maybe process this together. What do you think we could do to help ourselves be successful, Jacob?
We could add the opposite.
We could add the opposite. That would be my first move, and I'm just going to write it down so I can see how it looked before I did that. 5 plus. Well, what's going to become the opposite? There's nothing there to become the opposite. Well, there really is. Isn't there a 1 there? Yeah? Okay, so negative 1 times t plus 3, no subtraction in that one. And then negative 1 plus 2 times t add the opposite of 3, which is negative 3, right? I'm feeling like we're going to be far more successful now. Okay, now we have some simplifying to do, don't we? We're going to do some distributive property on both sides. So, it's going to work. We're going to do, this is going to get multiplied times both of those. This is going to get multiplied times both of those. And you all look like you're feeling fairly confident about what you're doing. Do you agree with me after my simplifying step? After doing distributive property? Yeah? Do we have any more simplifying to do? Yes. Both sides can be simplified, can't they? Yeah, we have some constants on both sides that can be put together. This can be added to that. This can be added to that. So the left side becomes what?
2 plus negative 1.
2 plus negative 1t equals negative 7 plus 2t. Again, this is kind of tricky. Like, which of those t's should we move? Should we get off that side? So here's maybe what the thought your brain needs to have. If I want to get the t's off of the left side, I'd have to do what to get rid of them? Have to add 1t, right? I'd have to add 1t. And then I'd do that on both sides, of course. Well, what if I moved them from the right side instead? What would I have to do on the right side? Subtract 2t. Well, then I'd have to do that over here. Which one seems friendlier? The first one, adding 1t, actually is friendlier. Yeah, let's add 1t to both sides. It doesn't matter. It really doesn't. We should all still get the same answer. But the problem is, sometimes you just create a little bit more work for yourself and you feel a little frustrated. So this side becomes 2. The other side becomes negative 7 plus 3t. Go ahead and finish that. They're being pretty good to us. We're getting integer answers. Anybody want to agree with me? We're going to make that our check problem because we all get the same thing. Okay? Awesome. Okay. Any questions, really, that I need to know? If you're going to, if you've mastered the subtraction step and you don't need to do the add the opposite and you're getting correct answers, stay with it. You don't have to change it to add the opposite. If you're not being so successful and you're not doing that, then it's time to get on board. And just trust me on this, that changing it to add the opposite, especially when these equations get more complicated, saves us headaches. Okay? And doesn't mean it's the answer for everything, but it does help. Okay, let's go to, you have the definition for identity in your notebooks, right? What is the definition for an identity? What's the definition for an identity? Sure?
An equation that is always true no matter what the value is substituted for a variable.
Oh, so an equation that is true no matter what you put in for the variable. So in other words, could you put a fraction in?
Yeah.
Could you put a negative number in?
Yes.
Could you put a decimal in?
Yes.
Could you put pi in? Yeah, when it says any number, it means any number that lives on the number line. Because it doesn't really matter what you put in, it should make it true. And what does making it true look like? Well, it looks like this side matches that side, right? So even if it doesn't match in the beginning, if eventually somewhere along the line it matches, you're like, huh, this is an identity. Because that side matches that side. And then what's the solution when you see that you have an identity? What do you say? The solution is?
Variables equals to a number.
All real numbers. That's how we say it. That's the number line. The number line are all the real numbers. Well, does anybody have this question? I didn't know there were such a thing as numbers that weren't real. Did you know there are numbers that are not real? What sci-fi movie are they in? Huh? There are imaginary numbers, also known as complex numbers. They don't live on the number line. They live in their own world. So all the numbers that live on the number line are called real numbers. So when we say the solution is all real numbers, we're saying any number you want to pick off the number line. How many numbers are there on the number line? An infinite number of them, a forever number of them. But those identities are limited to just all the real numbers. They can't include that other number set called the imaginary numbers. And you'll explore imaginary numbers more when you get to advanced algebra. I wish I got to teach you those because they're a lot of fun. But okay, so let's just put in here that when we have an identity, put this in your notes. Solution, I didn't mean to write that, solution is all real numbers. That's how we will state it. So you're solving along, you're solving this equation, and all of a sudden you discover you have an identity. One side of the equation looks exactly as the other side of the equation. You say, oh, that tells me the solution is all real numbers. And this is what you have to put on your paper. Where it says solve the equation, that would be your solution right there. You'd state all real numbers. Can you name every number on the number line? No, it's a lot easier to write that, isn't it? There's no way, you can't even live long enough to make that happen, can you? Okay, we're going to do number 10. We're still on page 43. So write down the equation. Okay. What should we do first?
The opposite.
Okay, add the opposite. Okay. Combine like terms. Okay, on the left side, can we do any combining?
No.
No. Okay, that side does not need any simplifying. How about the right side?
Yes.
Okay, so what can be combined?
Negative 2x.
Negative 2x and 9x can be brought together, and what do they become?
7x.
7x. And the 1 and the negative 5 can be brought together, and they become negative 4. And then we still have this other side of the equation right now, correct?
Ooh.
What happened? solution? We have an identity. Well, which one is it? Does the left side look exactly like the right side? Oh, they match. They match. This is an identity. Both sides are the same. I love it when both sides are the same. I get to stop and I get to write down solution is all real numbers. Well, how do we do a check problem? If the solution is all real numbers, how do you put all real numbers back into the original equation?
You change the variable.
You change the variable.
To anything.
To anything. Oh, so in other words, we're missing somebody. So there's 14 of you in here today. So if I gave every one of you your own value from the number line, none of you have the same value, and I made you all check it out, what should happen?
All get the same solution.
Everybody should get a true
Identity.
statement. Let's try a couple. Stay with me here. Let's try a couple. Let's use, I like the number 2. It's pretty easy to work with, right? Let's use 2. 7 times 2 is?
14.
14. 14 take away 4 is?
10.
10. Keep that thought, right? Okay, now let's come over here and do it. Negative 2 times 2 is?
Negative 4.
Negative 4. Negative 4 plus 1 is?
Negative 3.
Negative 3. 9 times 2 is? 18. Negative 3 plus 18 is? Negative 3 plus 18, 15, minus 5, 10. Was that our thought from the other side?
10.
Oh, look, I just randomly picked any number and it worked, didn't it? If I put negative 2 in there, do you think it would work?
Yes.
Well, how about negative 1? Let's just be a little easier on ourselves. How about negative 1? Should it work? Let's try. 7 times negative 1 is? Negative 7. Negative 7 take away 4? Negative 11. Hold that thought. Negative 2 times negative 1?
2.
2. Plus 1?
3.
3. 9 times negative 1?
Negative 9.
Negative 9. 3 plus negative 9?
Negative 6.
Negative 6. Negative 6 take away 5?
Negative 11.
Negative 11. Does that match what we got over there? That hold that thought? See, it doesn't matter. And if I could make life really miserable and say, okay, I want you to check out 1/3. I know you wouldn't like to do it, but would 1/3 check out? Yes. Would 0 check out? Would pi check out? Would negative 1 billion check out? Yeah. Any number you can come up with that's real, that lives on the number line, better check out, because it says the solution is all real numbers. Okay, anybody have any questions about that? We're going to try one more. Okay, number 14. And then we'll be done. Oh, this is oh no, we got to do number 11 first, sorry. I lied to you. Number 11. Okay, number 11, write down your equation. Well, I'm thinking, first thing I want to do is the old add the opposite. Even though I don't really need to do it, but I'm thinking some of you might. So we're going to do it. So I kind of keep working away, because you know what you're doing now, right? Do your sides match? Mine either. So can I say it's an identity? Can I stop? No, it's not an identity.
No solution.
Thinking I better get x's off of one side or the other, right? Huh. The x's cancel out over here and I have 6 left. Oh, the x's cancel out on the other side. I got negative 13 left. Hello?
There's no
No solution. we're gonna put, let's make this little note in our notes. The variables eliminated, they're gone. The variable, we'll say, we only have one variable really. The variable eliminated and the result is false. The variable eliminated, it disappeared, it's gone, there's none of it left. Well, if it eliminated and the result is false, that tells us no solution. There is not anything you can put in there for x that would make this a true equation. So I want you to notice something. If we would have back up here, not stopped when we did, what would we have done because we have x's on both sides? What would we have done to that equation? Because we have 7x here and we have a 7x here. What would we have done if we had kept going? Got variables on both sides.
You could take away the variables on both sides.
We could have taken 7x away from both sides, couldn't we have? And if we take 7x away from both sides, what do we end up with?
-4 equals
-4 equals -4. It's still an identity, isn't it? The variable eliminated again, didn't it? But this time we ended up with the result being true, because -4 does equal -4. So if you ever take it another step further, because you didn't recognize the identity there, and then you end up with something like -4 equals -4, you say to yourself, oh, that's an identity. The variable's no longer there. I got a true statement. That tells me it is all real numbers for a solution. But we can stop earlier if we recognize the identity before that. Does that make sense? Okay, now we're going to do number 14. The application problem. I need my book open here so that I can see what it's about. Okay, read the problem to yourself first of all. I'm going to use x because I like x. What's x going to represent in this situation? What don't we know?
The hours.
How many hours? X is the number of hours, okay? Well, the first question they ask is, the first thing we're supposed to do is find out how long is a job for which both companies will charge the same amount. Well, how are we going to figure that out? They didn't tell us what that amount's going to be, did they? We don't have anything to set it equal to. So what are we going to do? Help! I'm drowning.
We could set up an algebraic equation.
We could set up an algebraic equation, okay? Any ideas what would be the expressions in that algebraic equation? As you remember, an equation is an expression set equal to another expression. It says, an equation says, this over here is the same as that over there. They want to know when their cost will be the same. So couldn't we do cost for one company is the same as the cost for the other company? Well, how could we represent the cost for one of the companies? So let's do this. One company's cost I don't know, did they give these companies names? No, it's just a house painting company and then another painting company. So one company's cost, that first company then it says charges $376 plus $12 per hour. What algebraic expression could we use to represent charging $376 plus $12 per hour? Jacob?
376 plus 12x.
Hey, 376 plus 12x, thank goodness they only charged the 376 one time, and then $12 for every hour of painting. Well then the other companies cost. What algebraic expression can we use to represent the other company's cost, Chaser?
280 plus 15x.
Okay. Do you like it, class? Does that think that's gonna work? Okay, but now we need to do what with those expressions?
Add them.
No. Set them equal to each other. They want to know when that cost is the same as the other one's cost. So we just set up an equation where 376 plus 12x is set equal to 280 plus 15x. And we go about solving that. Go! You're answering A right now, okay? We're trying to figure out A right now. Do you agree with me that at 32 hours, that's when it wouldn't matter which company you went with? If it takes them 32 hours to paint your house, it doesn't matter which company? One charges less to start with and more per hour, and the other one vice versa. Okay, then it says B. I'll try to leave that there for those of you who might not have gotten that to accomplish. It says, what will that cost be? It's the same, remember, for either company, so what can we do? We don't even have to use the equation books. What can we use? Jacob?
We can just plug 32 in for x.
Into one of the expressions. Does it matter which one?
No.
No, because it's, remember, they're the same. So which one do you like better?
280.
Yeah, me too. 280 plus 3x. I'm going to put it in that one. I'm going to substitute in my 32. Well, 280 plus 32 times 3. Well, guess what? That's 96, because up there, 96 divided by 3 was 32. What's wrong?
It's showing to be 15.
15, everyone. Thank you very much for catching that. That would be a huge problem, wouldn't it? Okay, so now we got 15 times 32. Oh, we got to work a little harder. Well, 10 times 32 is, I'm trying to make things so it's calculators. 10 times 32 is 320. What's half of 320? Because 5 is half of 10. What's half of 320?
160.
160. What's 160 plus 320?
460.
Close. 320 plus 160.
380.
380.
How about 480? Well, those of you who want to use your calculator to check us out, feel free. 280 plus 480? 760, and those are dollars. Woo! That was a killer, wasn't it? Okay. Sorry that got, a little lengthy, but this is, I just got to kill you all in one day with notes, and tomorrow we won't have any, okay?